Hi, everyone. Hi to everyone who's just joined. Welcome to our first workshop of this week for the Polkadot Hackathon. Today, we'll be having a workshop with the Zeitgeist team on market creation and liquidity on Zeitgeist. And we're very lucky enough to have a very talented speaker with us today. So without further ado, I'd love to welcome on Malte to the stage for today's workshop.
All right, we're off.
Brilliant. Hi.
Thank you so much.
Awesome. I'll pass things over to you then.
Thank you for the introduction. Thank you all for coming. Very happy to see you all here. I'm Malte, a blockchain engineer, researcher at Zeitgeist. Really excited to be here. Thank you to Encode Club for organizing this, and really looking forward to getting into it. And that's what we'll do now. So what are we doing today? So as you guys may or may not know, Zeitgeist is a protocol for deploying, betting on, and resolving prediction markets. Now, prediction markets are quite complex financial instruments. They're not like your everyday BTC USDT pool. And we're going to talk about creating markets and deploying liquidity to them on Zeitgeist, how that works, and especially what some of the common pitfalls are that you might fall into. Now, and if you're building on Zeitgeist, chances are you're going to want to do that. Obviously, there's room for writing trading bots and the like, but what's really interesting about Zeitgeist and what really lies at the core of the protocol is that anyone really is able to create new markets on virtually anything in a permissionless manner if they're inclined to do so. And so that's what we're going to look at today. And we're also obviously going to talk about what prediction markets are, what they mean, and what they're for. Now, we'll be using, depending on like how things go, we may or may not look into some examples using our new version of the SDK. You can find documentation on all of this at docs.zeitgeist.com. I'm just going to post this in the chat. It's actually not .com, it's .pm. And we're also going to use some stuff that's not yet on there. We'll talk about that in a second. So I want to start off by taking a look at a typical Zeitgeist market. So this is like a typical prediction market that you can see here. It's a market in which you trade assets, tokens, but these tokens represent possible outcomes of future events. So what we have here, for example, is a market on who will win the UEFA Champions League Cup in 22-23. And if we scroll down here, you can see the different possible assets you can trade in this market. And you will find that each of the possible assets that's being traded is one of the possible clubs that can win the championship.
Hey, Malt, sorry to disturb. I'm not sure if you know, but we're not seeing your screen.
Oh, I'm terribly sorry. Yeah, of course. All right, let's go. Let's take it from the top. So, typical Zeitgeist market. Who will win the UEFA Champions League Cup in 22-23? So, that's what the market is about. We want to know what's going to happen in the future, and you can see here this is a list of possible outcomes, and so each of these outcomes represents a possible. Each of these tokens represents a possible outcome of the event, and you can see that depending on the price of the asset, there's a implied percentage associated with it. So for example, let's take Manchester City, goes for 51 cents, and there's an implied percentage of 51% probability. So there's actually a very important connection that the price in a prediction market implies a prediction. It implies a prediction for how probable it is for this particular club to win the cup. And as you can see here, there's quite a lot going on. You can see the history change over the course of the market, and you can see like the ending here especially is quite interesting. You can see Manchester and Real going head to head and then kind of splitting, and I guess maybe some interesting information came out when this happened right here. So that's what a prediction market is all about, is aggregating information. And these are the types of markets that run on Zeitgeist. Now, using these is quite complex. Now, obviously, you can just get into it, buy some tokens, see what happens. But these markets are high risk, high reward, right? Money moves incredibly quickly on these markets. So especially when you're on the side of creating and providing liquidity to these markets, you will want to configure them quite carefully. And we did kind of write a guide on this. Unfortunately, that's not yet published, but I can give you a link to like a temporary deployment of that guide. All right, we got some predictions in the chat here already. Cool. So I want to kind of summarize this guide, and I got a presentation prepared for this. So this is like the first big part of the talk now. So I want to kind of talk you through how trading and providing liquidity works, and what some of the things are that you might trip over when you're doing it for the first time. So let's get to it. So once again, like what are we offering on Zeitgeist here? So we actually have two types of markets that I want to talk about today. You've already seen the first one. The first one is our categorical markets. These ask like, how will a certain event play out? And there's also scalar markets, which go more into the direction of what will a certain measurement be in the future. So let's take an example. This could, for example, be a market. What will the Tesla stock price be at some point in the future? Or how many tornadoes will there be in the US in May? Or something like this. And in the future, there will actually be a third type of market, which is called a combinatorial market, which allows you to bet on questions like, how will a certain event play out contingent on another event? So if this happens, how likely is it that this other thing happens? If Y happens, how likely is it that X happens? These are currently in development. And we call the people who trade on our markets, we call them informants. And they buy tokens according to which outcomes they think are likely to occur. And they're rewarded if they get it right, and they're punished if they get it wrong. And this way we create useful predictions. And there's another side of that bet, and that is liquidity providers who make the markets. And they do this to gather information, to make the entire process possible. Now, let's take a look at these two sides of the bet, how they behave, and try to go into a little bit more detail here. So first side is trading, the side of the informants, right? So going to go a little bit into the math now, how categorical markets work. So suppose we have a categorical markets with outcomes A, B, blah, blah, blah. So A could be Manchester United, B could be Real Madrid, and so on. And suppose an informant believes that A has a certain probability, P. When would we expect them to buy A? When would that make sense? So what you try to do is you create these models in math for how things might play out, and one of the most elementary objects you can go for is expected value. Basically, that's like an average. You pretend that you run the experiments a lot of times, and expected value is kind of like the average over all these experiments. Expected value, like if anyone's played poker before, that's expected value is an incredibly important instrument in deciding whether to bet or raise or call or even fold in poker. So let's say the current price of the asset A is Q, and what we try to figure out is what's the expected value of my profit for buying A. And it's, well, let's go through this. Like, if I'm right, and if the event occurs and I'm right and it has a probability of P, then I have a probability of P of receiving $1, which is like all of the value of the losing tokens is transferred to the winning token. But I pay Q for the token. So this is my expected profit. And well, that's positive if P is larger than Q. So it really makes sense for an informant to buy an asset if the current price is lower than what they think the prediction should be. And this is actually like that is so great, because that means that it makes sense for informants to get into the market as long as they think the probabilities are not right. And they come into the market to fix the probabilities, basically. And that is like the core of prediction markets, is that informants get involved in these markets in order to improve the prediction. And the math says this makes sense for them as long as they're right, which is fantastic. And that is exactly the reason why prediction markets tend to be more precise than polls or even often expert opinion, because it gathers all this information and it incentivizes correct behavior. So that's how the categorical markets work. Now, scalar markets, they are a bit more complex. Now, scalar markets, I actually want to show you a scalar market first before we get into it. Let's take a look at a scalar market here. We have one here. So this is the type of thing you can run a market on, right? US dollar currency index end of Q2. So it's kind of like we're betting on what the dollar is probably going to be worth at the end of Q2. And you have a range on that market. You can see here, there's a range here, 100 to 107, and I think that's points, but don't ask me. You have two assets. And what do these assets mean? Well, they're long and short, and these obviously have, you've probably heard both terms already. So what these mean is, long basically means the prediction should be higher, and short means the prediction should be lower. The exact way this works is, the lower the price is of long, the closer the prediction is to the lower end of the spectrum. Or let's put it differently, the lower the price of long is, the higher the price is for short. And the higher the price of short is, the higher the prediction is to the lower end of the spectrum. And the same thing works the other way around as well for the higher end of the spectrum. So that's how Scalar Market works. You have these two assets, and depending like how their price looks, or what their price looks like, you get this prediction here in the middle, where right now it says it should be 102 at the end of Q2, and we'll see at the end of Q2 whether or not that's correct. I'm already showing you all this stuff that you're not supposed to see. So yeah, again, like Scalar Markets, they have this range A to B, and they have two assets, long and short, and they used to predict some value of future quantity or measurement in that range. And well, there you go. There's the example. What will the USD currency index be at the end of Q2 2023? And now the exact math is as follows. If P is the price of short and Q is the price of long, then the prediction is P times A plus Q times B. So, and again, you can see this here, right? If P is very large, so if the price of short is very large, then the price of Q is small, and P times A plus Q times B is very close to A. And the other way around, like if the price of Q is very large, if the price of long, which is Q, is very large, then the prediction V will be very close to B, because P will be small, Q will be large. So the higher the price of long, the closer the prediction is to B. The higher the price of short, the closer the prediction is to A. Now, when do we expect an informant to buy long or short? Well, let's say the current prediction is V, but the informant thinks it should be W. Now, I don't want to bore you with the details, actually, because that's a bit of a longer calculation. You can find it in the guide that I posted in the chat, and I encourage you to look at it. But it's not good material for a presentation. Now, a little bit of calculating gives you that the expected value of trading long is W minus V divided by a certain factor. In fact, the size of the range, right? And the expected value of trading short is V minus W divided by the size of the range, which means, well, the expected value of trading long is positive if W is larger than V, and the other way around for short, right? So again, this is the same like experience that we've had with the categorical markets. Is the traders are incentivized to change the prediction in a way. They're incentivized to change the prediction if they think it's wrong, and if they get it right, they get rewarded. So, summarize: our users are incentivized to fix the prediction of the market. And you know, they are at risk. It's a risky business, and but there's an equally high reward at stake. And the real question is, where does the reward come from? So, we haven't talked about that yet, and that brings us to the other side of the bet. We've talked about the informants and their trading. Now we have to talk about liquidity. So if you know anything about DeFi, you've heard about liquidity pools, about liquidity providers. You've probably heard about impermanent loss and the risks of providing liquidity. And we use that same model for Zeitgeist. So trading happens in a liquidity pool, and the liquidity providers who put their cash into these pools and make the markets, they take the other side of the bet. They are the people the traders are buying from. And really anyone can provide liquidity on a market on Zeitgeist. That's like everything is decentralized here. So if you want to get into the bet, you can get into that side of the bet as well. But you are taking the other side of the bet, so you're betting against all the informants. And that kind of raises the question, why would you do that? It does sound like trouble. Well, there are a couple of incentivizations here. Well, first of all, liquidity providers make the market. So if you want the market to exist, if you want the traders to, or the informants, to provide information, you have to make the market. So if you're interested in the information, you have to provide liquidity. And this is really important because if you can run a market on virtually anything on Zeitgeist. So if you're asking questions that are important for your business, maybe you're interested in, I don't know, what the price of gold is in next year or whatever. Maybe you want to buy a whole bunch of lumber for your business and you're wondering if you should wait a couple of months. That's one of the reasons why you might want to provide some liquidity. But there are other reasons. First of all, you can collect fees. And here's the kicker, right? So largest allowed fee is 10%. Now, if I remember correctly, most DEXs like Uniswap, Balancer, HydroDX, they have a fee of like 0.3%. It's a bit different on Zeitgeist because the trading is so high risk, high reward, you can actually get away with asking for a VIG this large. So this 10% is like on the lower end of excessive. Okay, so that's definitely something that you need to get right when you create markets like these. You can ask for a lot. You can ask for a lot higher fees than you would maybe expect coming from a classical DEX background. And the thing is, like, the idea of prediction markets is that the wisdom of the crowd is aggregated in these markets, and that might work, but it's not going to work all of the time. And if you have inside information on a topic, you can just profit off everybody else's ignorance. So if everybody is wrong, they are going to take the prediction in a direction that it's not supposed to go, and liquidity providers profit off of that as well. Nevertheless, LPing is inherently risky, and so one of the things that I really want to get into here is point out some basic strategies to mitigate some of these risks. So first thing is you need good initial predictions. So markets don't start at like a 50-50 prediction. They can, but they don't have to. Actually, I'm going to skip out of this presentation again and show you this. So if I create a new market, I'm just going to enter some nonsense here to make it work. I deploy a pool, I can set the initial prices. So let's say I have some kind of like a yes/no market, and I'm running, I don't know, I'm asking a question which is unlikely to resolve to yes. Then I can say, well, yes starts at 10 cents and no starts at 90 cents. So it becomes very expensive to buy no tokens at the start. And that protects you from a good deal of impermanent loss. So let's keep going. And then there's a thing called information shock. So one of the markets that we're running on Zeitgeist right now is whether or not Donald Trump will tweet in April. As you know, or may know, he got his Twitter account back in November, I believe, and hasn't used it since. So we want to know whether or not he's going to send off a tweet in April. And that market is live right now. Now, that exposes us to a great risk of information shock, because if Donald Trump tweets this second, people can just buy yes tokens, and there's virtually no downside for them there. So you want to protect against this sort of thing. And the thing that we could have done, for example, is to set so-called grace periods, which is the grace period basically means you close the market early. You let everybody make their predictions, and then you lock in those predictions. And you say, okay, that's it. Thank you, no more. And then you wait until the market resolves. And what we could have done in the example of this Donald Trump market is close the market end of March, lock everybody's prediction in, and then wait for a month and let the market resolve that then. And that protects you from, Donald Trump tweeting in the middle of the night, and you wake up the next morning and people have absolutely wrecked you because they saw the tweet. However, if that is for some reason inconvenient to do, and there are situations where that is the case, you can protect against information shock by just withdrawing liquidity when something happens. So what really helps is to just stay on top of the news and keep a lookout for what's happening. And since you're probably creating a market because you're interested in the subject anyways, that is definitely a thing that makes sense to do. So these are kind of like basic notes just on how to handle liquidity on Zeitgeist. And actually, that's the thing that I didn't mention, which is like, if you have any questions, please feel free to ask at any time. Like this is going to be much more interesting if you chime in. But this is kind of like the first part of the talk, and second part is really I want to try some of this stuff out using our next generation SDK, which is fresh off the assembly line, and I just want to present like some basic patterns when using that SDK. So if you guys decide to build on Zeitgeist, so that you kind of have a feel for how the SDK works. All right, so let's jump right in on a second. So here we go. First of all, actually, let's take a short look at our documentation page. So you can find the docs to the SDK under on the landing page, build, and then SDK v2. Now, it says here caution, because this is the next evolution of this Zeitgeist SDK, and it's fresh off the assembly line, and everything's still kind of in flux. So check back regularly and check GitHub, because things might change a little bit in the future. So that being said, let's try to do some work. So first of all, I've already showed you the app, so we haven't talked like too much about too much about the tech behind Zeitgeist. So Zeitgeist is a parachain on Polkadot. We actually started out as a parachain on Kusama and then migrated earlier this year. And we have this app here, which I already showed you, but we also have a testnet app, which is test.staging.zeitgeist.pm, which is basically our app, but it's connected to our testnet, which you can find on Polkadot.js. Our testnet is a Rococo parachain. You'll find it here, Zeitgeist Battery Station. So you can use the app both on the mainnet and on the testnet. And obviously, we'll be using the testnet for our demonstrations here. So first thing I want to do is just show you what a market looks like on chain. So we'll just take a look here. I've prepared a small, testing repository. So the SDK is written in TypeScript. I'm not super familiar with TypeScript, so I just hacked together a small testing environment. You guys probably know way better than I do how to create a whole TypeScript app. So, but I just want to show you how we initialize the SDK now and how we can pull a market from chain. So we just import some stuff. And take a second here. So yeah, let's do this example on the mainnet. And so the SDK is quote unquote just a wrapper, but it is so much more than that. But it is, you can think of it as a wrapper around the Polkadot.js API. And you can create an instance of the SDK simply by calling the create function and then passing a certain context to it. So right now we're using the context of the mainnet. If you want to use the testnet, we'll demonstrate that in a second. You'll just use a different context. And this SDK will be super useful in wrapping around the low-level Polkadot.js API, and really make a lot of stuff super convenient. And one of the examples is, let's say we just want to query a market. Let's take a look at a market on the main app. This is not the main app, so let's take a look at. This is why am I in this app again? Try that again. There you go. So let's say I want to pull the UA for Champions League market. So when you're playing with our app, you'll find that the URL, when you're in the market view, the URL has this number at the end here, and that's the market ID, and markets are indexed by their ID. So every market has a unique ID, and you can access the market using that ID. So in this case, it was market ID 21. And what we do now is we access SDK model markets get, and then we added we can do this a little prettier, where we access the market ID. And thing is, this is kind of like this Rust style programming that Polkadot.js imports to TypeScript is we need to, because we could add some kind of nonsense market ID here and then we wouldn't find a market, so we need to also unwrap it. So we basically assume that this is going to produce a market, and I think we may have to assume that this is not null afterwards. So this way, you can just pull a market from the chain, and we'll just log it to the console and see what happens. So that's the index, and let's see if I did everything correctly. That looks great. And I did not await this, so that's why it prints something nonsensical. All right, there you go. Actually, let's add a process exit here. So this is a market on Zeitgeist, and you can see that this is, as I said, like this is not just a BTC USDT pool. This is packing some information here, right? So first of all, you'll find like a longer description. Like this is actually funny because this is an old school description. Modern descriptions on Zeitgeist are in HTML. This is one that's still plain text. And well, a lot of info is just lost on the image associated with the market. But you'll also find some other stuff. Like you'll find, for example, the oracle that's responsible for resolving the market and the creator of the market. You'll find that the creator is not taking any fees. You also see that it was created in advised mode. That's one of the interesting things about Zeitgeist. So we have two tracks for creating markets. One is you can create markets permissionlessly. The other is you can go the advised route. Advised route is basically means your market isn't going live immediately, but instead the advisory committee, one of the decentralized what are they called? These decentralized collectives on the chain. Take a look at your market first and tell you whether or not your market is well phrased. For example, you may forget to add a token for a possible outcome of your event, or maybe your market is somehow underspecified. Maybe you forgot to specify a time zone for the, maybe let's take the USD index market. Maybe you forgot to specify the time zone you're using for the quarter. That's bad. So that's the kind of stuff that the advisory committee will warn you about. And that guarantees higher quality markets. And it also comes at a lower cost. Creating markets permissionlessly is a bit more costly. So, and you'll also find some other stuff, the outcome assets. So these are just, categorical outcomes. And here you'll find their interpretation. So each of them gets a ticker. And here we are back with Manchester City and Real Madrid and so on. And you'll also find something like info on the pool, right? So this isn't printing ideally, so maybe we'll take a look at that later on. We'll see. So this is what markets look like on chain, and as you probably guessed, it takes a while to set these up, but that's exactly what I want to do with you now, is set up a whole prediction market. And the first thing that we're going to do is, wait, actually, I'm going to pull up my notes here. All right, so let's create a market on how many tornadoes will be reported about in the US in the second quarter. So that's the type of thing that you could run a scalar market on Zeitgeist. And so let's get into that. And I'm going to have to do some copying because otherwise the writing is going to become excessive and it's probably going to be boring for you guys. So I'm just going to paste some of this stuff in. But before we do anything else, let me change the context here to battery station on testnet, so that I don't create anything on the main net, because that would cost money. And let's get rid of this stuff here. All right, and now we've got this SDK context is battery station, and let's create a market. And what you do is we have the system where you have these parameter objects which specify all of the parameters of market creation. And so I'll just paste this in here, and we'll go through these one by one, at least the interesting one. So first, signer will take care of that later. That's the account that signs the transaction. We'll have to create that manually in a second. Wait for finalization isn't that interesting. Base asset is very interesting. See, right now we're facilitating trading with our native token, and that exposes that is an idea for a couple of reasons. And what we really want to do in the future is allow people to use stable coins to facilitate trading on these markets. And the base asset is basically that. And right now we're using our native token ZTG, but in the future, thanks to the magic of XCM, you'll be able to use stable coins on Zeitgeist to fund these markets. And so then there's a thing called dispute mechanism. Because Zeitgeist is a permissionless protocol, we have limited control over how these markets resolve, and especially how well the oracle behaves. So one of the concerns, obviously, is let's say Donald Trump tweets in April. What if the oracle still reports that he didn't tweet? What do we do then? And the answer is, well, we have a dispute system. If you think the oracle is cheating you, you can start a dispute. And right now, we're using the authorized mechanism, which passes control over the resolution of the market to the aforementioned advisory committee, which is this decentralized committee. But in the future, we're working very hard on this. Stay tuned for that. There's actually going to be a decentralized court that any user will be able to participate in quite simply. And the creation type is the thing that we talked about earlier, right? We can go the advised route, let the advisory committee give you tips and improve your market, or you can say, you know what, I don't want any tips. I want to get my market out as soon as possible. Give me the permissionless route. And if you're building on Zeitgeist, I think permissionless is the way to go, because usually, like if you're creating a game and you want to run some prediction markets on that, you don't want to wait for the advisory committee to check your market, right? You want to get right into it. So permissionless is probably the way to go. Now, market type is categorical or scalar, right? And if you're specifying a scalar market, you'll want to specify the range, this A/B thing that we talked about earlier. And so one of the pitfalls here is you cannot just do, let's say we want to bet on 400 to 800 tornadoes, right? You cannot just do this. If you do this, you'll get something strange. That's because numbers on our chain are represented as fixed point numbers, and we're using 10 decimals after the point. So if you want to specify like 12.3, that's actually well, I gotta do this again and again. This is 1, and so this is 12, so this is 12.3, right? Because, well, floating point numbers are a big no-no on chain, right? And so that's how we represent numbers. So what's really useful is to use a function to let you calculate this type of thing. And I'm going to call this to decimal. Actually, let me undo some of this stuff. So it's correct again. So we want to convert numbers, and so we're going to write a function which does that for us, and you can actually do that using the base object, which is, like, I'm just going to put a comment here. So base is 10 to the power of 10, and base is basically like 1. We put this quote unquote 1 here. So in order to quickly convert numbers, you can do, I have my caps lock on. You can just do, what's the 2 number, right? Yeah, you can just do this. And so that makes these numbers, that converts them to the fixed point presentation, fixed point representation. Now, so that's the market type, and Oracle is, okay, so yeah, I already kind of talked about the Oracle. So the Oracle is the account that is responsible for reporting what eventually happened. So let's skip ahead for a second and look at the description of the market, because I prepared this in advance, and this is actually a market that's going to run on the mainnet in a while. So we want to know the number of tornadoes that occurred in the US in the second quarter of 23. Now, first of all, that's a difficult question, because like, if you look up what a tornado actually is, it's not that easy to tell whether or not something is a tornado or isn't a tornado. So you have to be very precise how you phrase your markets, right, so that they can resolve unambiguously. So so what we're actually going with is preliminary tornado sightings, and there's an institute, the Storm Prediction Center, and I don't know how well you can read this HTML here, but there's a Storm Prediction Center which regularly publishes a monthly and annual US tornado summaries report, and that specifies preliminary tornado sightings, and that's what we're going with in this market. So we want to know what the preliminary tornado sightings report is going to say about the second quarter. And the Oracle is going to be responsible for actually writing to the chain how many preliminary tornadoes were sighted. So that's a very important job, because if that doesn't work, none of this makes any sense, right? So it's very, very, very important that the Oracle does its job well. And usually the Oracle would just be the account that created the market, but it can be somebody else. And every market on Zeitgeist, moving on to period here, every market on Zeitgeist has a fixed starting and ending point. Now, you might be inclined to say, hey, let's just, since we're talking about the second quarter, let's just end the market on the 30th of June. You can do that. That's perfectly fine. However, this is the whole grace period thing. To protect ourselves from getting wrecked by traders, we can close the market early. In this case, I opted for 14 days early, and then set a grace period. And we're doing that in the next item, which is the deadlines item. And this grace period means the Oracle doesn't have to report the market until 14 days after the market has closed, which is on June 30th, if the market closes on June 16th. But trading cannot happen in that time. Trading is completely blocked, which is awesome. And that kind of protects us from getting into too much trouble. Now, deadlines, this is an interesting thing, is period. The market period is specified in timestamps. These are Unix timestamps in milliseconds. So the values that you have here are milliseconds since epoch, 1970, January 1st, midnight UTC, I believe. But because the SDK is so user-friendly, you can just use like you can use the TypeScript conveniences to initialize the period. But the deadlines, which are like Oracle durations, the time that the Oracle has to report, the grace period, and the dispute duration, which is the time that people have to dispute the market in case they don't like the Oracle report. These are all specified in blocks. So what you need is an additional function here, which converts days to blocks. And actually, in the interest of time, I think we can just copy that over because that's absolutely not interesting. So that we have a block time of 12 seconds. That's what you need to know. And yeah, that's kind of it, really. We've gone through all of these values. So let's move on to actually signing that thing. And yeah, we need to define this signer, and that is just straightforward. How that works exactly the way that you would do it when you're just using, bare bones Polkadot JS. So you'll just import this keyring utility, and I have, for reasons of security, I've stored my seed phrase in a .env file. So I'm going to configure that .env file and then read the mnemonic from the .env file. Then create a new keyring. So the type is just SF25519. And then we're going to create the signer object from the mnemonic. And I believe we have to use the exclamation. Yeah. So that defines the signer. And so then the SDK super usefully abstracts the whole signing process away from you, so you don't have to do all the complex stuff. You just call await SDK model markets create parent, and this gives you a response, and you can actually read the market from the response. You just have to pull some info from the response that's done using the saturate, and then you've got to unwrap the whole thing again for reasons, and we'll just print the market that it returns for us. And let's hope that works out. Did I save this? So let's see if I did everything correctly. I did not. Right. So this is a thing that sometimes happens. There's already a bug report on that. So what we got to do here is sometimes, I believe that's some kind of a race condition. So we got to import something from util crypto and just wait until the keyring is ready or something to prevent this race condition here. And I think now this should be fine. Well, that looks good. We're connecting, we're signing the transaction, stuff is happening, there you go. Boom, and it prints the new market. So this is the new market that we received, that we just created. And it tells us the market ID here. So let's take a look at our new market. And it's on the test net, so we'll go here, go to markets. Actually, looking at the wrong one. Actually created this market when I was practicing this talk, so it's already here under a different market ID. Totally ruined the surprise here. But there we go. there it is. And in all its glory, you can see here this slightly unwieldy blob of HTML is now printing beautifully. Only problem is the market doesn't have a liquidity pool, so let's fix that right away. And I'm going to go a little bit over time to do this. So that's kind of like the last thing we want to do here is deploy a liquidity pool, and that's really yeah, I mean that's a really important step in the whole process. So we still need the SDK, but we won't need all this market creation stuff here. Instead, we are going to save the market ID here for a second and pull the market from chain again. So actually, I gotta wait again. It should work. So, and we're going to create a new pool by calling market and then deploy swap pool and additional liquidity. And we're going to pass the parameter object directly into its value and into its one parameter. So, and this function has a couple of simple parameters here: amount, swap fee, and the weights. Now, what do these mean? Well, signer is clear. What's the amount? The amount is the amount of liquidity you want to provide. So if you want to provide 100 units of liquidity, that's what you'll enter. Actually, we'll just use our to-decimal function here, to-decimal, and say we want to provide 100 in liquidity. And this is 100 units of the base asset and 100 units of each outcome token. And swap fee is, well, we talked about this, right? The trading fee that LPs can take, and we have a convenience function here, which we can use to initialize this, and we'll just take a swap fee of 6%, and this field takes a string as parameter. And then the weights are actually where it gets really interesting. The weights determine the price of the initial prices. Remember the initial predictions that we talked about? I don't know if it's still up here. No, it's not. But this thing that I showed you here, if you create a new market, what else do I have to do this to work with? I did this right now, but you remember, you know, the actually, let me try to get this on the other. For some reason, this isn't. There you go. So remember this, and you could enter your initial prices, and these prices are set using, this is kind of like an implementation detail, but these are set using weights. And so we need to select the correct weights. And if you just want to go with the middle of the road prediction, you can just, you know, take the same weight for each outcome token. If you want to skew position, you need to use a higher weight for the more costly token, right? So this weights thing is a little bit more complex, but again, SDK to the rescue. they allow you to set the weights from a relative ratio. So, for example, if you want the short token, actually I gotta double check which of the tokens is, yeah, it's short first. If you want the short token to have a certain price, like 90 cents, and the long token price of 1, then you can use this weights from relative ratio function. But I made a mistake here. You actually have to pass an array and not just parameters like that. So you can just specify these weights, and it'll calculate. You can specify like a ratio, and the function will calculate the weights for you. And now from here on, it's just creating. Right here, here's the response. So this is again just calling this function. Obviously, it's an async function. You have to await it. Should go through, and then again it returns when you saturate the response and unwrap it. It should give you the newly deployed pool, and I believe this should go through. Note that it's very important that we specify the right market ID, otherwise we're deploying to the wrong pool, to the wrong market. And let's see if I can't type. So that, and and I forgot all the imports. So let's fix that right away. Swap fee from float and weights from relative ratio. Right, let's see if this works a little bit better. We're connected, and there we go. Apparently everything went through. This is our newly created pool. You can see it has an ID as well. Pools are also indexed by unique IDs. And let's go back to the test app and find our pool here. Let's just go straight by market ID. So this is our market, and wouldn't you know it, market is live. 2 months left of trading. This might take a while to load because we're using an indexer to load all the data. So this might be slightly delayed, unfortunately. So let's give it a short moment to load. Otherwise, I'm gonna have to ask you guys to check in later to see this. But it should actually. Let's try it again. There you go. And you can see we've set the prices in this way. It's properly set our initial prices. We have a initial prediction of 760 tornado sightings. If this initial prediction is good, this should be a good market for us. If it's far off, the informants will come in, they'll swoop in, and they'll correct the prediction. Maybe they will buy a lot of short tokens. They will push the price of long down, they'll push the price of short up. The prediction will go down. And then in 2 months' time, this market will resolve, and we'll figure out, how many tornadoes. By that point we'll know, but we will now have this prediction, and then we'll figure out how many it actually was, and we'll be able to resolve the market. And the traders will either be punished or rewarded. And I think there's a lot more to this, but that's all the time we have for today. I want to thank you so much for listening in, and hope this was helpful, and you'll have some fun, building on Zeitgeist. All right.
Hey, thanks, Mal. If you don't mind, we do have a couple of questions. Just
Great,
popping
great.
into the chat.
Oh,
Brilliant.
I meant to activate the bell, but I forgot.
No worries, no worries. If you don't mind, of course.
No, please.
Brilliant. Yes, so Alejandro said that they were trying to run this code, but it doesn't work. Do they have to initialize it with anything different to Zeitgeist SDK, Polkadot API? And then do you have any kind of guides regarding that?
Sorry, can you say that again? I was just searching for this.
Oh, it's in the chat?
Oh, right. Okay, wait. Right. Yeah, totally. Like, you have to check out the SDK and you're in the right spot. So there's a lot of examples there, and you will definitely run into some problems. As I said, things are always in flux right now. Hit us up on Discord, hit us up on GitHub. And so if any of these examples are outdated, just let us know. But most of these, like when I was preparing, I worked through most of these, and most of these just work fine, slight changes. So you should be fine just working through these examples. Thanks for the question.
Awesome. We do have, I think, 2 from Connor in the question section.
Right. Yeah, so first question, can LPs change the fees to be asymmetric if the market is becoming very one-sided? That's actually a cool feature. No, not right now. Actually, LPs can't change fees at all right now. But that's definitely something that we may want to think about. Is right now we're actually working a lot on giving LPs and market creators ways to be more incentivized to create more markets and give them more power to adapt markets to what we call information shock and changing situations. So I got to read the second question. What is the oracle that definitely states whether or not an event has occurred? Yeah, how do we ensure that the oracle is correct and unbiased? That's a very good question. Again, like that is kind of like the Achilles heel, right? If we can't make sure that works, we're screwed. So we have this dispute system. So right now, the way that things work is, after the oracle has handed in its report, there's a phase of I believe 4 to 14 days. And during that time, nothing happens except that we're listening for on-chain disputes. So you can take your on-chain account and you can say, you know what, I think the oracle was wrong. I want to start a dispute. And depending on what the dispute mechanism of the market is, that dispute is going to be resolved in one way or another. Right now, we have an on-chain collective that takes care of disputes. In the future, and this is very close to being completed, actually, you can look at the pull request on GitHub right now if you want. We will have a decentralized court, which everybody can join in, and which will be in charge of resolving these disputes. So it's very important to us that all these resolutions are decentralized. That's very important to us. Like we don't want any single individual to have power over how these markets resolve. And so while the oracle is a single entity that reports, it is under scrutiny of the decentralized court and the advisory committee. So that's how we ensure that oracles are honest. Thanks for the question. It's really important stuff.
Amazing. Connor saying he can't wait for the prediction market on what will the Court of Zeitgeist decide on Dispute X. So that's great to hear. Amazing.
Yeah, I'm actually looking forward to that as well. Cool, very cool idea.
Just to answer Alejandro's message, that is actually Encode Club's Discord, but feel free to pop in Zeitgeist Discord if you want. But we can also set up the Zeitgeist team, to join our technical question section. If that's the case, yeah, we can definitely sort that out so that if you guys have any questions, we can.
Yeah, cool.
Amazing. If there are no more questions, I guess I'll wrap things up here. Massive thank you to Zeitgeist and Malte for this amazing workshop. Definitely learned a lot and definitely very interesting. And yes, we are all very excited to see what the prediction market will be. But again, thanks everyone for turning up today. We have another session for tomorrow. It will be with the Subsocial team. So do stay tuned, same time again. But amazing. Thanks so much, guys, for coming. And thanks again. Have a lovely evening, everybody. Or morning or afternoon, wherever you are in the world. Bye, everyone.
Bye.